trigonometric functions of acute angles is what we're going to learn about in this lesson. So we're going to talk about the different types of angles first so that we can make sure that you know what an acute angle is. An acute angle measures less than 90 degrees. So its measure is less than 90 degrees. A right angle measures exactly 90 degrees, not a tenth of a degree less, not a tenth of a degree more, exactly 90 degrees. And an obtuse angle is an angle whose measure is greater than 90 degrees. Greater than 90 degrees, but less than 180 degrees. That's an obtuse angle. Now, an angle is formed by two rays that share the same endpoint. And the angle that they form is an acute angle, a right angle, or an obtuse angle. Now there's going to be some Greek letters that we name our angles with, and they are theta. So this is the Greek letter theta. So we'll say angle theta. Sometimes we'll use alpha. So alpha looks like a little fish, I've heard. Phi kind of looks like a theta, but the line is going more vertical than it is horizontal. And then we have beta. And beta kind of looks like a B. Now, right angles are what we're going to work with right here. We're going to talk about right triangles. So a right triangle is a triangle that has exactly one right angle, and then the other two angles are acute angles that measure, this is really, really important, two acute angles that measure, I don't want to color code this, so I better use a different color. Let's use pink. Two acute angles whose sum add to 90 degrees. That's really important. So these would be those angles. This angle right here and this angle right here. Those two angles would add to be 90 degrees. And then our one right angle, make that purple, the one right angle is this angle right here. And it's going to be the largest angle. The two acute angles, obviously, each one of those will measure less than 90 degrees, and then the right angle will be exactly 90 degrees. Now, when we talk about these right triangles, we're going to name the angles with capital letters. So I'll name the acute angles A and B, and the right angle C, and then the sides are labeled with lowercase letters. So side A will be across from angle A. Side B will be across or opposite angle B. And side C will be opposite angle C. The two sides that are opposite the acute angles are called legs. And the side that's opposite the right angle is called the hypotenuse. Now, in right triangle trigonometry, we have functions. We've got the sine of theta, that's a function. The cosine of theta is a function. And the tangent of theta is a function. So this is technically how we read it. We read it the I'm going to show my favorite bars so I don't have to keep doing that. We read it the sine of theta, and the abbreviation is sin theta, sin theta. So the sine of theta, we still call the abbreviation sine of theta. We don't say sin. It's sine of theta, and our abbreviation is sin theta. Cosine of theta, and our abbreviation is cos theta. And then tangent of theta, tan theta. And these functions are equal to a ratio of two side lengths. So the sine of theta is equal to the ratio of the opposite side length over the length of the hypotenuse. And the cosine of theta is equal to the length of the adjacent side over the length of the hypotenuse. And the tangent of theta is equal to the length of the opposite side over the length of the hypotenuse. There's a shortcut to remember this, and it is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now there's 3 more trigonometric functions, and they are the cosecant of theta, the secant of theta, and the cotangent of theta. Now the shortcut for cosecant is CSC theta, and that function is equal to the length of the hypotenuse over the length of the opposite side. And the secant of theta is SEC theta, and it is equal to the length of the hypotenuse over the length of the adjacent side. And I can write it like this: hypotenuse opposite, hypotenuse adjacent. And the cotangent of theta is equal to the ratio of the length of the adjacent side over the length of the opposite side. So when I write these 6 trigonometric functions, sometimes I'll write SOHCAHTOA so I can remember that sine is opposite over hypotenuse, cosine of theta is adjacent over hypotenuse. Here we'll color this: opposite over hypotenuse, adjacent over hypotenuse, and then the tangent is opposite over adjacent. SOHCAHTOA. Now I always write cosecant across from sine, the secant of theta across from cosine of theta, and the cotangent of theta across from the tangent of theta. And that's because the cosecant is the reciprocal of sine. So the sine of theta is opposite over hypotenuse. The cosecant of theta is hypotenuse over opposite. The cosine of theta is the adjacent side over the hypotenuse, where the secant of theta is equal to the length of the the hypotenuse over the adjacent. And then the tangent of theta is equal to the ratio of the opposite side over the adjacent side, and the cotangent of theta is the reciprocal, adjacent over opposite. So these trig functions, sine and cosecant, cosine of theta and secant of theta, tangent of theta and cotangent of theta, these are reciprocal functions. So these are reciprocal functions, and that's because their ratios are reciprocals of one another. Let me show you an example. We've got this right triangle, 5, 12, 13 are the side lengths. We want to find the 6 trig function values of the specified angle. Now I'm going to need a little bit more room, so I'm going to take this and I'm going to copy it onto another page. I tend to write egg. So the first thing I'm going to do is I'm going to write sine of theta, cosine of theta, and then of course equals, and then tangent of theta equals, and then cosecant of theta equals, secant of theta equals, and cotangent of theta equals. step 1, I'm going to, the specified angle, I'm going to draw a circle around that specified angle, which I'm going to call the reference angle. So the specified angle is theta. I'm going to draw a circle about that angle. And I'm going to then draw an arrow going to the opposite side. So the side opposite theta is the one that has the side length of 5. And I'm going to call that O for opposite. The other leg that makes the right angle is the adjacent side. And then the side that's across from the right angle is always the hypotenuse. Now the sine of theta is the ratio of the opposite over the hypotenuse. So the opposite is 5 and the hypotenuse is 13. The cosine of theta is the adjacent side, which is 12, over the hypotenuse, which is 13. And the tangent of theta is the opposite side of 5 over the adjacent side of 12. Now the cosecant of theta is equal to the hypotenuse over the opposite side. So the hypotenuse is 13, the opposite is 5. And you can see that the cosecant of theta and the sine of theta are reciprocal values. The secant of theta is a reciprocal value of the cosine of theta, so it is 13 over 12. And the cotangent of theta is the reciprocal of the tangent of theta, so it will be 12 over 5. Excellent. Okay, let's do an example. And I think that maybe this example could even be a try. So what you're going to do first to find the 6 trig values is you're going to write sine of theta, cosine of theta, tangent of theta, and then across from sine of theta is cosecant of theta always. Across from cosine is secant of theta always. And across from tangent of theta is cotangent of theta always. And that will help you remember which functions are reciprocals of one another. So the sine of theta, and I wrote theta, but it shouldn't have been theta. What should it have been? That's the wonderful thing about an eraser, is that if you're me, you get a lot of use out of it. It's alpha. So I'm going to draw a circle around the reference angle alpha with an arrow going to the opposite side. So I label the side length to opposite. And then the other leg that makes up the right angle is the adjacent side now. And then the hypotenuse is always across from the right angle. It is a length of 4. So sine is opposite over hypotenuse. So that will be 2 over 4, which is 1 over 2. The cosine of alpha is going to be the adjacent side over the hypotenuse. So that's 2 times the square root of 3 over 4, which reduces to the square root of 3 over 2. And the tangent of alpha is opposite over adjacent. So that's 2 over 2 square root of 3, which is 1 over the square root of 3. Because the 2's cancel. And then if we rationalize this, it's the square root of 3 over 3. So I'm going to rationalize this real quick. You multiply the numerator and the denominator by square root of 3 over square root of 3 so that your denominator becomes rational. The cosecant of alpha is going to be the reciprocal of sine, so it will be 4 over 2 or 2 over 1, which is 2. The secant of alpha will be the reciprocal, so that's 2 over the square root of 3, which is going to rationalize to be 2 times the square root of 3 over 3. We get that by multiplying by the square root of 3 over the square root of 3. And that's how we get 2 times the square root of 3 over 3. And the cotangent of alpha is going to be, I'm going to look at this one in the middle right here, because that's the easiest one to take the reciprocal of, and it is the square root of 3. Now, given a function value, let's find the 5 other trig function values. The cosine of theta is equal to 3 over 5. So how would we find the other 5? Well, I'm going to write all 6 of them down, once again, because it helps me remember which trig functions go together. Cosecant goes with sine, and secant of theta goes with cosine of theta. And this is indeed a theta, so that's a good thing. And then cotangent of theta. Sometimes I'm going to say theta when it's really an alpha or a beta, and that's because I use theta all the time. Okay, the sine of theta. Well, I can draw a picture, and I can label one of the acute angles theta. I can draw an arrow going to the opposite side. The adjacent side will be the other leg that makes the right angle, and the hypotenuse is always across from the right angle. Well, the hypotenuse is 5. The opposite side we don't know, but the adjacent side is 3. Well, how can we figure out what the opposite side is? We can figure out the opposite side by saying 3 squared plus the opposite side squared. I don't know what it is, so I'm going to call it x squared, is equal to the hypotenuse squared, which is 5 squared. So we have 25 minus 9 is 16. X squared equals 16. So this side must be a 4. So the opposite side is a 4. The adjacent side is a 3. And the hypotenuse is equal to a 5. So the sine of theta will be opposite over hypotenuse, which will be 4 over 5. Cosine of theta was already given. It's 3 over 5. And the tangent of theta is opposite over adjacent, 4 over 3. Now, the sine of theta and the cosine of theta, because they are both over the opposite, the hypotenuse, they're opposite over hypotenuse, adjacent over hypotenuse. The hypotenuse will always be the biggest side, right? It's going to be the biggest side length. So the hypotenuse, since it's the biggest side length, will always be bigger in the denominator for sine and cosine. Therefore, your sine of theta and your cosine of theta will always be between -1 and +1. It'll always be less than 1. It'll always be smaller than 1. Always smaller than 1. We're not going to talk about negatives yet. So it's always going to be less than 1, which means that our cosecant and secant, because those are the reciprocals, those will always be greater than 1. Always be greater than 1. So the cosecant of theta is 5 over 4, and the secant of theta is 5 over 3. The cotangent of theta, it's the reciprocal of tangent of theta, is going to be 3 over 4. Now the tangent of theta, the cotangent of theta, those values can be any value. They don't have to be smaller than 1 or greater than 1. So let's write that down. Sine and cosine, those will always be less than 1. However, your cosecant and secant, those values will always be greater than 1. And tangent and cotangent can be any values. Now, one more thing before we go to the next video. Let's talk about Pythagorean triples. Pythagorean triples are a good fact to know so that you're not having to use the Pythagorean theorem. Pythagorean triples make a right angle, make a right triangle. So side lengths that are whole numbers that form side lengths that are whole numbers that form a right triangle. So 3, 4, 5, those three sides are side lengths. 5 is the hypotenuse because it's always the biggest side. 3 and 4 are the legs. 3, 4, and 5. 3 squared plus 4 squared equals 5 squared. Check. 9 plus 16 equals 25. 3, 4, 5. Those are what we call a parent of a triple. And then from those, so instructors, teachers, they'll like to multiply each side by 2. 6, 8, 10 could be the side lengths of a triangle, where 10 is the hypotenuse. We could take 3 times 3, which is 9, 4 times 3, which is 12, 5 times 3, which is 15. Those would be sides of a right triangle. We can multiply by 4 and get 12, 16, and 20. These all stem from the 3, 4, 5 triangle. I can take 3 times 10, 4 times 10, 5 times 10. Those are the sides of a right triangle. Those aren't the only ones though. 3, 4, 5 is a parent. I like to call this the parent, and then this part's the family, right? Another parent would be, what's another good one? 7, 24, 25. That's a kind of a popular one. And from that, you can make 14, 48, and 50. You can multiply by 3. You can multiply by 10, 70, 240, 250. So there's lots of other families that you can make from the parent of 7, 24, 25. And 7, 24, 25 will also form a right triangle. Another popular one, 5, 12, 13. It's a really popular one. 10, 24, 26. Maybe multiply by 3. You could do 15, 36, 39. You could do by 10, 50, 120, 130. And so on and so forth. Dot, dot, dot. Just keeps going. Another one that's popular is 8, 15, 17. And you know the drill. You can multiply by 2, multiply by 2, multiply by 2. There's another one that is a good one. 20, 21, 29. That's another good one. So knowing these parents, the 3, 4, 5, 7, 24, 25, 5, 12, 13, 8, 15, 17, 20, 21, 29, knowing those parent triples will be very helpful, most especially when you're taking a test, because when you're taking a test, it takes a little bit of time to go off to the side and try and multiply out to find out what your missing side length is. If you know these triples, you might be able to identify and save yourself time in case on the test, or when you're working on a problem, it happens to be a triple. If you recognize it, it'll save you a lot of time.